We studied how by using thumb rule, how it will the direction of magnetic field. Okay, so here we put a compass and we can see. Now we studied 3 or 4 or 5 cases. Okay, tomorrow you're having test, and tomorrow I will take your test till activity 13.6, page number 229. Okay, remember, activity, this activity is completed. Okay, activity 3.6 on page number 229. Okay, you will have test of these things. Okay, till, okay, I'm not talking about only. Okay, up to activity 13.6 and page 229. So this is activity, this is same activity. Okay, this is activity 13.6. so we studied this, that how compass needle deflect, and we studied 3 cases or 4 cases, that how when we change resistance, when we change resistance, we studied 4 case. Okay, so how we change resistance. In this time resistance was high, this time resistance was slightly high, at this time resistance was medium, at this time resistance was very low. So at this time current was very poor, at this time current was poor, at this time current was medium, and at this time current was very higher. So we studied how the magnetic field lines are produced. We studied how the magnetic field lines are produced. In this case, very weak magnetic field line is produced. So we studied this thing, and we studied also that the direction of magnetic current can affect the direction of magnetic field lines. Okay, the direction of magnetic current, for sure affect the direction of magnetic field line. This was the question I told you, I asked it for today. Okay, so this is our another activity which I started. So let's explain this. Okay, first of all, it is same thing. Okay, it is same thing, it is nothing extra, it is the same thing. It is same thing, but here we are provided with one cardboard and only one direction, and in this case we are provided, these are two cardboards, and the electric current are providing it electric, the direction of electricity in two directions. So these are two separate experiment number A and experiment number B. In experiment number A, the direction of current is in this direction, so the magnetic field lines, okay, this is our thumb rule, right thumb rule. Okay, the rule of Maxwell. Okay, so in the rule of Maxwell, the direction of this current considered as thumb, and the direction or the rotation, or this could be iron flakes. Okay, we studied this, how we can use this. Sometimes we can use iron flakes. Okay, and this is our copper wire. So how iron flakes will rotate, or how they make circle. In this case, this is the direction of electric current, and this is how the magnetic field lines form. Okay, so these are two separate experiments, definitely, and in this case we are merging these two. Okay, we are just merging these two experiments. Okay, this is the same experiment, A or B, but they are separate. In this case they are separate. Okay, and in this case we just merged this. Okay, because in this case you can see that this is a single cardboard, this is a single cardboard, you can see this is a single cardboard, and in single cardboard we are we are using a copper coil. So direction of current in this case it is this side, and in this case it is this side. So you can also say this side and this is this side. Okay, so this, there are two magnetic two directions. This is direction A and this is direction B. Okay, and same cardboard, but you can see, as you can see, the direction of field lines. Okay, the direction of field lines. Okay, here the direction of field lines is here, and here the direction of field line is here. Okay, so in this case, case number B, the direction of field line is here, and case number A, the direction of field line is here. Okay, as you can see, though you are, if you are not able to see this, this is diagram is directly from your NCERT book. Okay, this is, and this is okay, so this is the direction of current, this is the direction of current, and these are the direction of magnetic field lines. Okay, so I just merged two experiments. Okay, so this is the experiment, this was the experiment. So what we studied on last class, that if I consider a loop, okay, we have studied three type of magnetic field. First magnetic field produces when there is a this type of first magnetic field produces when there is a uh, magnet bar, okay. So this type of magnetic field is produces, okay. Second type we studied a straight conductor, straight, okay, by using thumb rule. It was our thumb rule. The basic thing I face the problem that they disappear or they get lost, okay. So this is another rule, which is rule of Maxwell. We studied this by using a straight conductor. This is our straight conductor, okay. And in second case I'm just using, so this is for magnet, this is for straight conductor, and the last case or another case, okay, this is not definitely last case. In this case we are using a circular loop, okay, a circular loop. So in this circular loop we can find two direction, though we can find so many directions, but right now we are going to study only about these two directions. We are going to study about only these two direction, A direction and B direction, because the structure of the circular loops provides two directions, okay. So there will be two direction and two direction of magnetic field, so we just merge this, okay. So in this case, okay, so this is our diagram from our book, and I'm just using this diagram because it is showing us very clear direction of magnetic field line. So this is, in this case there is this direction, okay, I'm noting it A, and in this case there is this direction, okay, and I'm denoting it B. So in A case you can see the direction is like this, okay, this is the direction, okay, of magnetic field lines, okay. This is the diagram from our NCERT book, but I'm taking this one because it is showing me very clear cut thing, okay, because this side the cardboard is not very clear, it is hiding, and in this case the cardboard is, it is in front of you, okay, this cardboard is in front of you. That's why I'm using this. You can draw this or you can draw this. This is same thing, okay. This is also circular, you can see. So in this case, this is the direction of magnetic, this is the direction of current, and this is the direction of magnetic field line. You can see this is the direction of magnetic field line, okay. And in this case this is B, the direction of current, okay, and this is the direction of magnetic field lines, as you can see, okay. So this is current and this is magnetic field line, okay. So both in this type of circular loop, okay, you can find this by using Maxwell thumb rule, or I told you about the pen rule. Definitely if you're facing any problem to finding this type of direction, okay, how could I find this type of direction? In this case this is the direction and this is magnetic field line. In this case this is the direction and this is the direction of magnetic field line. So this is magnetic field line and this is current, okay, and here this is current and this is magnetic field line, okay. So I gave you an exercise. I gave you this exercise. You are thinking that ma'am is why ma'am is giving us so much homework, and this is, hectic and problem, and I can't have this much time. But I gave you this exercise on our WhatsApp group only because I want to make you things easier, that you will be able to find out the direction of magnetic field line by using your thumb or by using the pen method, which I told you. So you can use any type of thing, just draw it and send it to me. So this is plus and this is minus, okay. So this is the direction of current, this is the direction of current, okay. In this case this is the direction of current, and this case this is the direction of current, okay. So there will be magnetic field lines. So here the magnetic field lines like this, and in this case the magnetic field lines are like this, okay. So they will be increasing magnetic field lines will be increasing, and this is like, but a time will come that there will be, we can find a line like this, okay, in between these two, okay, this line in between these two, okay. Why this line appear? Why this line appear? The question is why this line appear? Because this line appear because it cannot go to this side, or it cannot go to this side, or it cannot rotate like this side, or it cannot rotate like this side, because it is something mid. Okay, and it is confused that where should I go? Should I go to the like this? Should I go to like this? Okay, should I go to like this, or should I go to like this? Okay, so which type of direction I follow? So it never tilt or never turn to any direction, and it is like this straight line. Okay, you can also this type of straight line. Okay, this straight line, this diagram is from our book. This is the straight line. You can see this. Hopefully you can see this straight line. Okay, this is another line, and these lines are getting bigger, but the mid line is always straight, because where should I go? Where should it go? Should I go here, or should I follow this one, or should I go this pathway? So it is just a straight line. Okay, so this is, remember, this is our real diagram from our book, but I'm just right now I'm using this because I think this is more easier for me. Okay, so this is something. Okay, so this was our diagram. Okay, this was our diagram. Okay, now this was our diagram, and you studied how the electric current move and how electric current path. Okay, this is positive pole and this is negative pole. Remember that positive pole is always south pole and negative pole is always north pole. Don't forget this, because if you forget this, you will be unable to answer so many questions. Positive is south and negative is north. So the current will always flow from south to north. Okay, so it is like, it is following like this, because this is positive and negative, so they are following like this. Okay, now I just tilted. Okay, I just rotated this diagram like this. Okay, this is the horizontal version, and I just make it vertical version. Okay, now this is a vertical version. Okay, so this circular loop, okay, this is just, this was horizontal here and it is vertical here. Okay, nothing is changed, I just changed the direction. This is positive and this is negative. Okay, so how electricity will flow? Electricity will flow in same direction from positive to negative. So here electricity will flow like this. Okay, now electricity will flow like this, and here electricity will flow like this. Okay, now just see about the direction of magnetic field lines. The direction of magnetic field line is here like this. Okay, this is case A, this is current, and this is magnetic field lines. Okay, you can also see this. Okay, you can also see this. If you are using a laptop or computer, then definitely you can see this, or if you are not able to see this, just make a copy pen and draw it, or your book is full of diagrams like this. Okay, I just rotated this. Okay, just rotated this. You can take a screenshot of this, so it will be easier for you to understand. Okay, in this case the direction of the direction of current is like this. I just rotated this. Okay, just rotate, this is just rotated form, and the direction of magnetic field line is here. Okay, magnetic field line. Okay, so this is the direction of current and this is magnetic field line, and here this is the direction of current and this is magnetic field lines. Okay, nothing will change, and you can see a midline. Okay, this is the midline. It is a confused line. Where should I go? So it goes just straight, because it is not tilting, or it is not attracting towards any type of pole. Or if you how these lines will appear, that if we use iron flakes. Okay, and if we are using iron flakes, and this is our copper wire, suppose this is our copper wire. Okay, this is our copper wire, this is our copper wire, and if I use iron flakes, okay, so how these iron flakes will aggregate? So iron flakes will aggregate in this manner here. Okay, in this manner, and in this case iron flakes will aggregate in this manner. Okay, and some of the iron flakes will form a straight line. Some iron flakes will form a straight line, because they can't go towards this side, or they can't go over towards this side, because it is, midpoint. Okay, when there are two powerful people, you are standing in between two powerful people. Okay, or you cannot choose anyone between your mother or father, both are important for you, so you will just go straight. Okay, that I'm both side, or I'm for no side. Okay, so it will just go straight. I'm for both side or I'm for no side. Okay, so that's why it will make a straight line. Okay, so how I can draw this? Can I draw it like this? This is a circular loop. Okay, it is positive, it is no negative. How the electric current is flowing? Electric current is flowing like this. This is electric current, this is electric current, and this is how the direction of magnetic field line, and in this case this is how the direction of magnetic field line. Okay, now this is the magnetic field lines. Okay, now can I consider this tilted part as this circular loop? This is also circular loop, this is a circular loop. Okay, this is circular loop. You can see it like it is oval, but this is not oval. Okay, this is a side view, so this circular loop is looking like oval, but this is not oval, it is circular. Okay, perfectly circular. So this is positive and this is negative. So how this is current is flowing, same thing I'm drawing here. Okay, okay, so there will be magnetic field lines here and there will be magnetic field lines here for sure. So you can see the magnetic field lines here. Okay, first of all it was like this, horizontal. Second, I tilted this, and this is the tilted form. Okay, this is the tilted form. Same thing I'm drawing here. This how the current is flowing, how the current is flowing, and how the magnetic lines are created. This is how the magnetic lines are created, magnetic field lines are created. And one thing you can see in between these two, this line which is present in between these two, okay, this is the same line which cannot go either this side or either this side. There will be so many larger magnetic field lines, but finally a place will come, which sorry, a place will come which will feel same magnetic force. This is the midpoint which will feel the same magnetic force. Okay, so this line will be straight and it is not tilting to any side or not shifting to any side. Okay, so it will just straight. Okay, so this was horizontal method. Horizontal. Okay, and it is using a cardboard. Okay, so that's why we can feel or we can see the magnetic lines which are made up of iron. Okay, so this was our diagram. This was our diagram from our book. So this is a circular loop. You can see this is positive, this is negative, how current will flow, and this is cardboard for sure we are using. And in on this cardboard there are some sprinkles of metal or iron, so you can see the magnetic field lines. Okay, you can see the magnetic field lines. Okay, now I just tilted this, and how I tilted this, that I made it like this and removed this cardboard. So there will be definitely magnetic field lines will produce. Okay, magnetic field lines will produce in same manner like this. In same manner it will produce, but we are not able to see this, we just have to imagine this. Okay, because we remove this cardboard, so how can we place iron flakes? So it is imaginary thing. Okay, this is our imaginary thing. What is imaginary here? These field lines are imaginary, definitely they will form, but here as we are using this cardboard. Okay, this cardboard. Okay, but here this cardboard is removed, so this is just a circular form, and just remove this cardboard. Okay, so as this cardboard is removed, there will definitely, it is a conductor, it is a conductor, this wire is a conductor, it will form circular lines, but we just have to assume that circular lines are produced. We cannot see these field lines as we can see here. Okay, so these two are same, this one and this one, both of them are same. Here the position is horizontal. Okay, and in this case the position is vertical. That's it, nothing changed. This is vertical position. Okay, this is vertical position. Okay, this is this one, and this is this one, or this is this one, this circular loops, and this is this circular loop. Okay, so we are just going for this huge circular loop. Okay, so we studied about three things. What did we study? We studied about magnetic field lines in bar magnet, magnetic field lines in straight conductor, current carrying conductor. Third, magnetic field lines in this loop which was in horizontal position. Okay, these are horizontal. If we draw like this, they are horizontal, and if I draw like this, they will be vertical. Okay, so we studied this in horizontal case. This is horizontal case. Okay, same thing. This is a horizontal case, and now we are studying this is a vertical case. That's it. Okay, now this is same circular loop. Don't get confused. This is looking oval, but actually this is circular. Okay, this is circular. Okay, so circular loop when it is vertical. Okay, now look at here. This is positive and this is negative. So how current will flow? Current will flow here in this direction. Okay, as it will flow here this direction. So rather than drawing any type of loops and circle, I'm drawing something like this. Okay, so this is the direction of current in this case. This is the direction of current in this case, and in this case this is the direction of current, and current will again come down like this. Okay, because it will flow like this. Current will flow like this. Okay, this is south pole and this is north pole. Okay, because it have to flow from south to north, so this is how it come. Now definitely if this is the direction, okay, if this is the direction, okay, so this is our conductor. Okay, so current will flow like this in this case. So definitely there will be the formation of magnetic field line, and the magnetic field line, the direction is like this. Okay, and we are not going to study about this case. We are just moving to this case. Okay, in this case this is the direction of current and this is our wire. So definitely magnetic field lines will produce, and the direction of magnetic field line is like this. Okay, only one thing you need to practice is like the direction of magnetic field lines. Okay, so here this is current and this is the direction of magnetic field line, and in this case this is the current. Okay, and this is the direction of magnetic field lines. You can see in this case or in this case, you can see in both of the cases. Okay, now these lines are growing greater and greater. How they are growing greater and greater? You can see that this is the smallest magnetic field line, this is largest circle, this is another large circle, this is another large circle. In this case the circles are getting larger and larger, as we have seen in case of magnet that these circles are getting larger and larger. Okay, these circles are getting larger. How we can see this? Okay, these are going from north to south. We studied how this compass needle is always tilted towards this, so this is going from north to south. So these are also getting larger. So as we can see, they are also getting larger from both these sides. They are getting larger. Okay, but this is the midpoint. You can see that this is our apparatus case A, or this is case B. So this is something which cannot show any path because it cannot go here and it cannot go here. Okay, it is something in between, because this line feels equal magnetic field from this case and from this case. It will form equality, so it will like this. Okay, straight. Now this is converted into north pole and this convert into south pole. Automatically they were converted into north and south. Now I'm going to tell you that how this will. Okay, there is no line, and till there are large circles. Okay, so why this pole is considered north and why this pole is considered at south? Okay, just look at this. This was our magnet. Okay, and this was our south pole and this was our north pole. Okay, we used a compass, and by using a compass we made some magnetic field lines, and the needle of compass was same like here. It was always tilted towards south pole. Okay, it was the magnetic field lines which we did this experiment by using a compass. Okay, we did this experiment. You can see this experiment with this did this. I'm just showing you one thing again. Okay, I'm just showing you this bar magnet, and we did this same thing. Okay, and by which we obtained this thing. You can see how this is this compass, these lines are always, they start from north and they end up to south. We did this, okay, by using of this compass, okay. And there are some properties of magnetic field lines. There are so many properties of magnetic field lines. Hopefully I can find this. Yeah, so these magnetic field lines, okay, so these are properties of magnetic field lines. First, that magnetic field lines direct from north to south outside. Okay, this was something we studied on previous classes, okay. So in this case, okay, what you can see by previous experiment, that these magnetic field lines, if I want to complete this circle, I tell you that if I want to complete this circle, this is my magnet, okay, this is my south pole, this is my north pole. And how we did this? By using this compass. So I'm just making a single line, okay, this is, okay. So what, or if I want to complete this line, what should I do? If I want to complete this line, I will complete it like this. We studied this, okay. So this is a complete thing. This is south pole, this is north pole, and this is a complete thing, okay. We can draw this, okay, for sure we can draw this for the second one, okay. So this is a complete thing, okay. For second one I'm using another color, so it will not make you confused, okay. So there is a complete circle, there is a complete circle, okay. In this case, okay, now look at this bar magnet. What does it shows? It shows that magnetic field lines go from south to north. It goes from, sorry, north to south, okay, north to south. How they go north to south? It was our structure, we studied this, our magnetic yeah, how it goes, look how it goes. It goes north to south, okay, when it is outside, north to south outside, okay. So yeah, it is going north to south, north to south when it is out, okay. And if I want to complete this, it is south to north inside, okay. We can claim this, and we can originate this, or we can use, we can draw this, and we have studied this, and we did this experiment, okay. So north to south outside, and south to north inside, okay. Now I'm indicating that this pole is north, this is south. Why so? Look at here, case A, okay, how they are moving, how they are moving, they are moving, they are moving, okay, they are moving north to south outside, okay, and north to south outside, okay. In this case, look, north to south outside, how they are moving. This is north and this is south, so they are moving like this, their direction, you can see their direction, north to south outside, okay, and south to north inside. This is south pole and this is north pole. So here you can see how the circle completes. Here they are outside, north to south. Here they are outside, north to south. And in this case, it is inside. They are moving inside. So this is south and this is north. So north to south outside, north to south outside. And you can see, you can see and south to north, okay, this is inside part, so south to north inside, and You can see south to north, south to north, inside. Okay, so it claims both thing as this magnet does. Okay, then where the magnetic field lines north to goes north to south when it is outside, north to south. You can see the direction how it goes. It goes like north and south, so it goes north to south, south when it is outside. It goes north to south when it is outside. Okay, and south to north in encircling. Okay, south to north inside, or you can see south to north. This is south pole and this is north pole. So south to north, south to north inside. Okay, tell me if you are having any problem in understanding this concept. This is our circular loop. Okay, all of the magnet, electromagnet, definitely this is electromagnet. This is electromagnet because this is copper wire, and we made this electromagnet by conducting electricity. All these, or this current carrying conductor, or if you use this in horizontal way, or if you use this in vertical way, all of them will show same concept. So this is circular loop and it shows same thing. That's why these north and south poles are originated. Tell me if you are having any problem in the understanding this concept, or this concept is very clear to you. Tell me. Should I move on to another topic? No problem. Okay. Salia, same time you are not having any problem. Salia, are you clear? Can you draw this and can you explain this, that why these two poles originated? Okay. Now I'm moving to another thing point. Okay. Now I think this is most easier thing for you. Just remember this, or you can draw this. Now I'm moving to another point. This is known as solenoid. Okay, I'm just giving you idea of solenoid, and we will start rest of the chapter on tomorrow. Tomorrow you're having test, don't forget. And test will be not MCQ type. I can ask any type of question. Okay, remember page number 229, activity 13.6. Page number 229, activity up to, okay, up to this, from starting to. Okay, this is solenoid. What is solenoid? You can see this simple thing. This is a battery. Okay, this is battery. This is positive terminal. This is negative terminal. Just take a wire. This is copper wire. Okay, and we studied till now, we studied three types of magnetic field, four types of magnetic field lines created. First in bar magnet. Okay, and how they draw their magnetic field lines. Okay, north to south outside and south to north inside. Okay, second we studied a straight current carrying conductor and we use thumb rule. Okay, but definitely there will be south and north pole. Okay, if it is the direction, it is south and north pole, and if it is the direction, it is south and it is north pole. So definitely they will show something, magnetic field lines. In third case we studied about a circular loop, and circular loop in two manner. First was vertical or horizontal, and second was vertical or horizontal. You can use anything. Okay, in these two cases both of them will show same results, same originating and same magnetic field lines and same thing. Next case we are going to study about this solenoid. In this solenoid, okay, in this solenoid you will have to study something. It is bar magnet. It is simple wire. It is a coil. It is a circle, and here we are going to make so many circles. Okay, and these circles of wire, in first case this was bar magnet, in second case it was just straight line. It was this part. Okay, and we called this as straight conductor. Okay, in third case a loop was there. In third case a loop was there. In third case, a loop was there. Okay, it was a loop. Okay, so it was a loop, or it was a loop. Okay, it was simple loop. Okay, but in fourth case, we are going to study about a conductor which is making this much of loops. You can see how these loops are formed. Okay, you can see the loops. Okay, here you can see how many loops are produced. So these many loops are produced. So in this case, we will conduct our electricity. We will make this loopy thing. We will make this loopy thing our conductor. Okay, so this type of loops, when we make this loop a conduct electromagnet. Okay, right now it is a conductor, and when we, okay, right now it is conductor and wire, and if we join it with this battery, or this is jointed with the battery, now it is known as electromagnet. So now we will study that how we can make this looped body. Okay, so many loops are present, so many loops which are created by copper wire, or you can use soft iron. Okay, either you can use copper or you can use soft iron, you can use both things. So it is loopy thing, and these loopy things, when this loopy things is electromagnet, okay, just we are pass electricity, so this loopy thing will convert into electromagnet, and this type of electromagnet is known as solenoid. It is known as solenoid. Okay, don't forget that this is solenoid. What is solenoid? There are so many loops we created, and now it is electromagnet, and this electromagnet, okay, it was a straight conductor which was electromagnet. There was loops, circles, those were electromagnets, and now we are having these loopy things, and these loopy things is electromagnet, but this loopy thing is known as solenoid. Okay, solenoid. Okay, definitely we are going to put this in circuit, and we will study about its pole and positive and negative signs. So we will take our next class on Monday. If you have any type of problem regarding to exams in your school, you can ask me, and tomorrow you will have science test at 6:30 p.m. Okay, so we'll take our next class on Monday, and if you have any doubt and any problem, talk to me without any hesitation. Okay, so text me at WhatsApp. Text me at WhatsApp. Time is running out. Solenoid, 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 solenoid.